Okay, welcome back, College Algebra. This is a continuation of section 7-1. If you recall, in the first video, we introduced what a system of equations is and talked about how to find the solution to a system of equations, okay, which, remember, the solution is where two lines cross and can be found algebraically. We learned the substitution method last time. This time we're going to learn a method called the elimination method. Okay. Now before we do this, I ask you please not to become married to one method or the other. There really are times when elimination is faster. There really are times when substitution is faster. Either one should work anytime, but don't close your mind off for one of the two methods. They both work really well. So this is still 7-1, and this time we're going to be talking about the elimination. Okay. So I'm going to write a system of equations up here. Let's see, 8x, 7y, 2, and 9x minus 4y. Okay, so there's a nice system of equations. Now, I still have the variables as x and y. If you get a system of equations where the variables are, say, like a and b, or p and q, whatever, when you write the ordered pair, just go in alphabetical order. If the variables were a and b, your ordered pair solution would be a, comma, b. Okay. So anyway, now the elimination method works best when you have two linear equations that are in standard form. Another way to say that is if the terms with x in them are stacked up on top of each other, the terms with y in them are stacked up on top of each other, you've got your equal signs stacked up, and then your constant term, the terms without a variable at all, are also stacked up. And the goal in the elimination method is to add the two equations, okay, and have one of the two variables be eliminated in the process. Okay, so let's just think about what would happen if I just went ahead and added these two equations. Well, 8x plus 9x would give me 17x. 7y plus negative 4y would give me plus 3y. And then 52 plus 11 would give me 63. Now, I've done a perfectly legitimate operation there. However, if you look at the result, this equation, 17x plus 3y equals 63, it didn't really do me much good because this third equation here, this one, still has both an x variable and a y variable in it. So I didn't, by adding those two, I wasn't able to eliminate one of the two variables. So I think we should just erase that and think of possibly a better plan. Well, if I think about it, in order for one of the variables to be eliminated, what I'd have to have is I'd have to have the coefficients on either the two x variables or the two y variables be equal and opposite. For instance, if that was an 8, that coefficient, and that was a negative 8, well, 8x plus negative 8x would give me 0. Okay, and one of the variables would be eliminated. Well, that's not the case here. So let's talk about how we can make that be the case. Well, let's think about it. Obviously they're not the same. They're not equal and opposite right now. What we usually do is we find a common multiple between, say, 8 and 9. All right, the least common multiple between those two numbers would be 72. 8 times 9 is 72. And so what I could do is I could multiply the top equation by a positive 9. Now watch what would happen. 9 times 8x would give me 72x. Then I can multiply the entire bottom equation by negative 8. because negative 8 times 9x would give me negative 72x. 72x plus negative 72x would be 0 x's, and the x's would be eliminated. So that's what I'm going to do. So let's go ahead. Now remember, I can do this, the equations will stay balanced as long as I multiply 9 by both sides, as long as I multiply negative 8 by both sides of the equation. So I'll do the top equation first. I'll get 72x plus 63y equals, and then let's see, is that 468, I think. And then let's see, that would give me negative 72x. Negative times a negative will give me a positive 32y. And negative 8 times 11 will be negative 88. Okay. Now, this set of equations, this system of equations is equivalent to this system of equations. I've just multiplied one of them by, the top equation by 9 and the bottom equation by negative 8. But look at the beautiful things that happen when I add the two equations this time.
Beautiful.
Well, 72x plus negative 72x, that's 0. I can write a 0 there if I want to, or I can just write nothing at all, which is my choice. Okay, then I'm going to add 63y plus 32y, which I think will give me 95y. And then I'll add 468 plus negative 88, which I think gives me 308. And notice, by adding those two equations this time, we were able to eliminate the one of the two variables. In this case, we eliminated the x variable. Now I can solve this equation for y. Okay, so I'm going to divide both sides by 95. And I think I get y is that 4, I believe. No, sorry. No, it's 4. Yeah, it's 4. Forgive me for that little interlude there.
Never.
Okay. Y is 4. That's the y coordinate of the solution to this system. Now, I still need the x coordinate of the solution. So since I know y is 4, I can substitute that number 4 back into, I've got 4 equations to choose from. I can use either of the two original equations, or I can use either of these two equations that I created myself. I'm going to use one of the original two. In fact, maybe I'll just use that first one. So I'm substituting 4 in for y, since y is 4. So I'm going to put a 4 right there. So I'm going to get 8x plus 7, and then instead of writing times y, I'm going to write times 4 equals 52. And notice I have an equation there that has only an x in it. So I get 8x plus 28 equals 52. Subtracting 28 from each side, I get 8x equals, let's see, that would be 24. And then dividing both sides by 8 gives me x equals 3. So now I know the x and the y coordinates of the solution. I write them as a word pair, 3, 4. So at that point, remember, that's the solution to the original system. That's the point where those two lines, if I were to graph them on the same set of axes, that's where those two lines would cross. Listen, in 7-1, there are some applications problems. We'll see if anybody has a question on that. I can certainly make a video that explains how to do one of them. I will tell you this, the mixture problem in particular might require some assistance, but see if you can get finished with just the basic problems. You can email me if you have questions and such, and maybe we'll take tomorrow just to work on 7-1, and maybe we can post a video on 7-2 a little bit later. Thanks for watching. Have a